Greetings! So, we are starting into chapter 12 now, and first one is classifying triangles and talking about angles of triangles. So, you should kind of already be familiar with these, but we're just going to recap. So, classifying triangles by sides, no congruent sides, that would be a scalene triangle. And then two congruent sides is isosceles. Now, here's something kind of weird. Depending on which book you look at, an isosceles triangle is either defined as having at least two congruent sides or having exactly two congruent sides with a third side not congruent, which is kind of annoying. I would say exactly two congruent sides, because if it has a third congruent side, then it would be more accurate to just call it an equilateral triangle. Our last one, so equilateral triangle. So I'm sticking with isosceles triangle has exactly or only two congruent sides, because otherwise we really should just call it an equilateral triangle, give it the most specific name possible. So then by angles, three acute angles, well, that would be an acute triangle. One right angle would be a right triangle. One obtuse angle would be an obtuse triangle. And then last one, we don't use this name a ton, but three congruent angles would be equiangular. And equilateral triangles are equiangular and vice versa. So equiangular triangles are also technically acute triangles because all three of those are acute, but if they're all the same, we could call them equiangular triangles. And we're not really going to spend time having you classify these on the notes, because I'm pretty confident you can do that, but just know that you will be classifying them by angles and sides. So if you have a triangle that has three acute angles and no congruent sides, it would be an acute scalene triangle, or you could have a right isosceles triangle, or an obtuse scalene triangle, or a right scalene triangle. So you got different ways you can do this, but you're going to be classifying by angles and sides on those. All right, so then, talking about angles of triangles. So exterior angles will come up a little bit later, but here's how we go. So interior angles of a triangle are the ones inside of it. Exterior angles of a triangle are supplementary with the interior angles, or basically you'd get an exterior angle by just extending one side of the triangle. So, talking about interior angles here though, so the sum of the measures of the interior angles of triangle is 180 degrees. I'm guessing a lot of you probably already knew that. So measure of angle A plus measure of angle B plus measure of angle C always has to be 180 degrees if it's a triangle. So corollary, which is kind of just like a side result of this theorem, is that the acute angles of a right triangle are complementary. So if this is a right triangle, A and B would have to add together to equal 90 degrees, which should make sense because you'd have 180 total, and if you subtract the 90 degrees that you already have, then you'd have 90 degrees left to split between angles A and B. So then, let's find the measure of these missing angles. So I would recommend, or I think you should, pause it and do whatever you can, try them out. If you need to see a couple examples first, fine, watch a couple, then pause it, then try some on your own. So here is where we are at. And there are definitely multiple ways you can do this. All right, so first one, the total of all of these three should be 180. So one thing we could do is set up an equation. 85 plus 63 plus x is equal to 180. Then we can start trying to get x by itself here. So 85 plus 63 would be 148 plus x is equal to 180. Then you subtract 148, and that would give you that angle x is equal to 32 degrees. All right. So the other way people will do this, which is really the same thing, is they'll just add these together and say, okay, 63 plus 85 is 148. And I know the total needs to be 180, so if I take 180 and I subtract 148, then that gives me 32, which has to be the remaining angle. So you can think of it either way. All right then, so number 2. So you can do this a couple ways. You can use this kind of shortcut here in knowing that these two together have to be just 90 degrees because this one's already 90. So x plus 61 is equal to 90. Subtract 61, and you get that x is 29 degrees. So you could just get that doing 90 minus 61, or if you wanted to go the full 180 route, those two together would be 151 degrees. And then if you took 180 minus 151, that also gives you 29 degrees. So lots of ways to get there. All right then, number 3. So setting up an equation is really going to be the way to go here. So you could set up this plus 90 equals 180, or you could go the shorter route and do 2x plus 3x plus 5 is equal to 90. Then we can combine some stuff. 2x and 3x would be 5x plus 5 equals 90. Subtract 5, we get 5x equals 85. And then dividing by 5, we get that x is equal to 17. Now, that's great, but our original direction said to find the missing angles, so technically we are not done yet. We still need to plug x back in to find the other ones. So if I plug in x here is 17, so 2 times 17 would be 34 degrees. So that one's 34 degrees. And then for the other one, you could do 3 times 17 plus 5, or you already know that these two have to be 90, so you could also just do 90 minus 34 degrees. Either way you do it, you should get that this third angle right here is 56 degrees. So should get the same answer either way for those two angles. All right then, continuing on to the back here. So number 4 has a bit going on here. So there is something that you need to know. It should be something you've learned before, but I'm going to just remind you that vertical angles, the ones directly across from each other, are congruent. So that's something you'll need to remember for this. So vertical angles are congruent. So if you had any two lines crossing, the angles directly across from each other are congruent. So those two would be congruent to each other. Whoa. I don't know if you can even see that at all now that I'm looking at this. Oof, no, that's right in the bad. There we go. Sorry, I was in a bad spot. So vertical angles are congruent. So those two are congruent, and that would also mean that the two directly across from each other that way would be congruent. So that's something you would need to know for this one. So for this one, you've got lots of different things going on here. You basically have some overlapping triangles here. So one of the triangles you could look at first is this one right here, and this will help us find angle Y here, which is one of the exterior angles. So in this triangle, I need to find this angle here, basically. Then I can find Y. So I've got a 50 degrees and a 74 degrees. So 50 plus 74 would give me a total of 124. And then I can subtract that from 180. So 180 minus 124 ends up giving me 56 degrees. So this angle down in here is 56 degrees, but then these two would be 180 together with Y. So I can do 180 minus 56, and that gives me that Y is equal to 124 degrees. So that's something we'll actually look at later. Okay, so to find x, we're looking at this bigger kind of triangle here, this one. But in order to find x, we need to know this angle right here. So to find this angle, we're actually going to look at this smaller triangle inside here. So vertical angles are congruent, which means I know that this angle right here is going to be 85 degrees. So I can use that to find this last little corner angle here. So 50 plus 85 is 135. And then if I take 180 minus 135, that's going to give me 45. So I know then that this corner angle here is 45 degrees. And now I can use that to find x in this bigger triangle right here. So I've got a 68 and a 45 degree angle. So 68 plus 45 is 113. Now I can subtract that from 180. And I get that our value of x is 67 degrees. So there's how that one works. Quite a few more steps, but same basic idea. All right, then number 5. So if you haven't tried it, try it, or wait and I'll set it up and then you can try. So this shows measures of various angles of roof supports. We want to know the measure of angle 1 right here. And remember that these two markings are trying to say that these angles are going to be the same amount. So if you want to call it x, that one's x, that one's also x. So you can kind of think of this one a couple different ways. If you wanted to set up like an equation to find it, you'd have something like x plus 110 is equal to 180. Or, and you'll see that we get the same thing, right? So that's 2x plus 110 equals 180. Or you can kind of reason through it. So you know that you already have 110 degrees right here. So if you subtract that from 180, that's going to give you 70 degrees. So then you know you have 70 degrees split evenly between those two angles there. So if you take that 70 and you divide it by 2, then you get that the measure of angle 1 is 35 degrees. And you'd see that you get the same thing. This is basically what you would have got if you continued to solve that one right there. All right, then number 6. So, measure of one acute angle of a right triangle is 12 more than 3 times the measure of the other acute angle. Find the measure of each acute angle of the right triangle. So there's a lot going on in this question. So it might help to draw a picture. I would always recommend drawing a picture and stuff like this. So let's draw a picture. So we know we have a right triangle. So it's not perfect, but whatever. It's a right triangle. Okay. So we have a right triangle. And we don't know what either of the acute angles are, but we know that one is 12 more than 3 times the measure of the other. So I'm just going to call one of these acute angles x. So I'm going to call that x. So then the other one is 12 more than 3 times x. So we can write that as 3 times x plus 12, or 3x plus 12. So this other angle up here is 3x plus 12. Now I should be able to use that to find the value of x, and then to plug that back in to find the other 2 angles. So you could pause this and find x, or find those 2 angles, and then check. So you can go a couple routes. You can do total is 180, but I already know this one's 90, so these 2 have to add to be 90. So that's the way I'm going to do it. So x plus 3x plus 12 is equal to 90. So that would be 4x plus 12 is equal to 90. And then I can keep going, so subtract 12. I get 4x is equal to 78. And then I divide by 4. And I get that x is equal to 19.5 degrees. So this is one of the acute angles, this one right here. So the other acute angle then, we just need to plug this back in to find. So it would be 3 times that, and then plus 12. So if you multiply 3 times 19.5, and then you add 12 to it, you end up getting 70.5 degrees. So those are the measures of the two acute angles of that right triangle. And you could double check. 19.5 plus 70.5 does end up giving you 90 total, so that checks out. All right then, so last thing here, exterior angle theorem. So for the most part, this is just a shortcut that you can use or not use depending on the setup. There are some where you will absolutely need to use this, but usually you don't have to use it. It's just a shortcut. So if you remember kind of up here that when we added these together, that ended up being 124, and y was 124, that's pretty much what this theorem is. So the measure of an exterior angle of a triangle is equal to the sum of the measure of the two non-adjacent interior angles. And these are also called remote interior angles, so you may hear it either way. So basically, the two that are not right touching one, basically, so the two across from it. So this is saying, in other words, that the measure of angle A plus the measure of angle B is equal to the measure of angle 1. So then, let's look at a few examples here. So some of these you can skip if you feel like you've got it down, but I do want you to do at least the first couple. 3 you could do for extra practice or skip. And number 6 is one I definitely want you to do, because this one you have to use this theorem. It doesn't end up that you can do it the other way. So number 1. So the fast way, or I would say the fastest way, is to use our theorem here. So we need to know the measure of angle 1. Our theorem tells us we can add these remote interior angles and get the measure of angle 1. So based on the theorem, it should just be that it's 80 plus 60. So measure of angle 1 is 140 degrees. So we can do it that way. The other way we would do this is you can find this third angle, kind of like we did on the problem up there. So I know that this is 140, and I know total should be 180. So that gives me that this angle in here is 40 degrees. But then I need to find not that, but the measure of angle 1. So these two together, along a straight line, should be 180. So I can do 180 minus 40, and then I get that measure of angle 1 is 140 degrees. So it works either way. You get 140 degrees both ways. The theorem, I think, is just a little bit faster, but if this is easier for you, you can do it that way most of the time. All right then, so try out number 2. Then unpause to check. Right. So you could do this different ways. You could use that this has to be 180 together to find that this is 102, and then use that to find the third angle, to find x. Or you can just go with the theorem route. So those two added together, x plus 55, needs to be equal to that exterior angle of 78. So I can just subtract 55, and I get that the measure of that angle there is 23 degrees. And if I had gone the other way, you should see that we'll see that I get the same thing. So if I had figured out that that's 102, then 102 plus 55 ends up giving you 157. And if you take 180 minus 157, that also gives you 23 degrees. So either way you do it, you get 23 degrees. All right, so you can skip number 3 if you want, or you can do it. If you're going to do it, pause it, try it. Pause, try number 4, 5, 6. So give them all a try, and then I'll go through them. So number 3, again, you could do it like this either way, or fastest way is just add them together. So 50 plus 65 would be 115 degrees. So that exterior angle is just 115 degrees. Okay, number 4. So those two added together is 145. So 2x plus 95 equals 145. Subtract 95, subtract 95. So 2x is equal to 50. And now depending on what it was asking us to do, the directions weren't super clear here, but we might be done here. So this angle itself is 50 degrees, but if we were trying to find x, then we would continue and divide by 2, and we'd get that x is 25. Or you could get x as 25, plug it back in, and you get that that's 50 degrees. All right. Number 5, then. So those two added together should be 58 degrees. So x plus x equals 58. 2x is 58 degrees. So if you divide by 2, you get that that is 29 degrees. Okay, and then try number 6. If you haven't already, pause it, try it out. This one you can't do this other way because you don't have enough information to find what this angle is, because this is also has x. All right, so checking this one then. So these two added together, again, should be equal to that exterior one. So we've got 2x plus 6 plus 36 is equal to 4x minus 18. So that's 2x plus 42 is equal to 4x minus 18. And we got to get all the x's to the same side, all the numbers to the same side. So either subtract 2x or subtract 4x. Should work either way. I'm going to subtract 2x. So then I've got 42 is equal to 2x minus 18. So add 18, add 18. So we get that 2x is equal to 60. So divide by 2 and I get x equals 30. So if we're supposed to find the value of x, then we're done. But if it was asking us to find the measure of the angles, we do need to plug x back in. So then here we've got 2 times 30 degrees plus 6 would be 60 plus 6. So this one is 66 degrees. And then you can plug it in if you want to find the other one, 4 times 30 minus 18. Or you can just add these together because it should be that, 36 plus 66. So whichever way you choose to do it, you should get that this exterior one is 102 degrees. And that is it for this one. So, best of luck and goodbye.